On October 29, 2024, something impossible happened. An interstellar comet passing our sun suddenly blazed 400 times brighter, a jump so extreme it defies every model we have. Then it fired 7 distinct jets of gas, and here's what shook NASA. Some were shooting directly into the sun, against the solar wind that should blow everything away. Normal comets don't do this. They can't do this. But 3I/ATLAS just did. And then it accelerated on its own, twice as fast as any comet we've ever tracked. Is this frozen rock reacting to solar radiation in ways we've never witnessed? Let's dive right in. Here's the timing that makes this story even stranger. 3I/ATLAS arrived during solar maximum, the sun's 11-year peak activity cycle that began in October 2024. During this phase, our star becomes a violent storm of coronal mass ejections and solar flares. The same charged particles creating brilliant auroras across Earth's skies are now slamming into this interstellar visitor. And what happened next changed everything. NASA's Mars orbiter captured the highest resolution image we'll ever get of 3I/ATLAS on October 29th. When it arrived, scientists saw just a fuzzy white dot. Disappointing. But while that photograph seemed underwhelming, 2 other satellites were watching something that would send shockwaves through the astronomical community. America's GOES and Europe's SOHO satellites equipped with special coronagraph telescopes weren't looking for comets. They were monitoring solar weather when 3I/ATLAS entered their view. What these satellites recorded has left experts struggling for explanations. As the object approached perihelion, the brightness didn't just increase, it exploded. Within days, 3I/ATLAS became 400 times brighter than it had been. A typical comet passing the sun might brighten 10 to 100 times. This was 4 times beyond the most extreme case ever recorded. What could generate that much light? Each explanation came with serious problems. Then came the color change, and this is where things moved from unusual to genuinely bizarre. When we first spotted 3I/ATLAS last summer between Mars and Jupiter, it reflected red light, normal for comets. Then in September, it mysteriously turned green. Now, approaching the sun, it changed to blue. Look at the light spectrum. Red sits on one end, blue on the opposite end, green in the middle. When solar radiation heats a comet, we expect colors to shift toward red. But 3I/ATLAS moved in the complete opposite direction. It's like watching water flow uphill. This suggests the object released a massive cloud of bright blue gas. But we don't know what gas could create this effect. Nothing in comet chemistry textbooks glows blue like this under these conditions. Some scientists considered a breakup event. Maybe the sun was tearing it apart. That would explain the brightness and color change. Many comets do fragment near stars. Except 3I/ATLAS emerged from the other side completely intact. Still in one piece. Still moving. Which brings us to what happened next, and this is where the story becomes genuinely unsettling. Following that blue flash, 3I/ATLAS began moving in ways that broke every rule. Scientists measure something called non-gravitational acceleration, or NGA. The sun's gravity affects everything predictably. But if an object moves differently than calculations predict, something else is pushing it. For comets, venting gas creates a small rocket effect, causing them to wobble slightly, maybe drift a few kilometers daily. But 3I/ATLAS was different from the start. For months, it showed almost zero NGA. It flew in a perfectly straight line toward the sun. No wobble, no drift. This alone was odd because most comets meander as they release gas unevenly. Then, on October 29th, everything changed. The object suddenly veered 135 kilometers away from the sun, while accelerating 60 kilometers in another direction. Combined effect, 200 kilometers per day of NGA. The only other interstellar comet we've studied, 2 I/Borisov, showed about 100 kilometers per day. So 3 I/ATLAS is moving twice as fast. But here's the shocking part. Comet Hale-Bopp, one of the most active comets in modern history, experienced roughly 2 kilometers per day of NGA. That means 3 I/ATLAS is accelerating at 100 times the rate of Hale-Bopp. Either this object is venting gas at impossible rates, or something else is pushing it through space. 9 days later, November 8th, telescopes captured something unprecedented. 7 distinct jets of gas erupting from 3 I/ATLAS's surface. Most pointed away from the sun, which makes sense. The sun produces solar wind, charged particles flowing outward at 400 kilometers per second. This wind shapes comet tails, always pushing material away. But at least 2 jets were firing directly toward the sun. Imagine spraying a garden hose upward into hurricane winds. That's what these jets were doing, pushing material against one of the most powerful forces in the solar system. Normal comets, like Hale-Bopp, have tail structures that flow smoothly away from the sun in one broad, fuzzy fan. 3 I/ATLAS had 7 separate jets, each maintaining sharp definition despite spinning once every 16 hours. That rotation should smear everything into a blur, but each jet held its structure, suggesting incredibly powerful, focused outgassing from specific locations. Then, in less than 24 hours, everything transformed again. By November 9th, those 7 jets had merged into one massive plume, stretching nearly 3 million kilometers into space, 8 times the Earth-Moon distance. And this plume didn't look like a typical comet tail. It resembled smoke rising from a fire, dense and turbulent. More importantly, that anti-tail pointing toward the sun was still there, now measuring about 1 million kilometers long, still pushing against solar wind. We first noticed this sun-facing emission back in summer when 3 I/ATLAS was between Mars and Jupiter. Scientists debated whether it was an optical illusion. It wasn't. Now that the object has passed through the most intense radiation environment in the inner solar system, this anti-tail persists. It's real, measurable, and defies our understanding of solar radiation pressure. To survive this violent outgassing without breaking apart, 3 I/ATLAS must be massive. Early estimates suggested 5 kilometers across, but given what we've witnessed, scientists now believe it's closer to 10 kilometers in diameter. That's 20 times larger than Oumuamua, 10 times bigger than 2 I/Borisov. And size matters here. The bigger an object, the lower its chances of surviving billions of years in interstellar space. Space isn't empty. There are rogue asteroids, debris fields, gravitational disturbances. A small rock might dodge these hazards, but a 10-kilometer object is a massive target. The probability of it arriving here intact approaches astronomical improbability. Let me walk you through what we know for certain. 3 I/ATLAS brightened 400 times faster than any comet should. It changed color opposite to what physics predicts. It maintained perfect trajectory for months, then suddenly accelerated at twice the rate of any known interstellar object. It fires jets toward the sun against impossible solar wind pressure. It maintains a growing anti-tail in the most hostile radiation environment in our solar system. And it's 10 kilometers across, having survived an interstellar journey that should have destroyed it. Every single fact pushes the boundaries of comet behavior. Combined in one object, we've entered something entirely unprecedented. Right now, NASA teams are analyzing data from spacecraft throughout the solar system. They're looking for chemical signatures, analyzing light spectrums, building models to understand those acceleration events. But there's no consensus yet. No simple explanation that accounts for everything we're seeing. Does this mean it's artificial? The universe is vast and capable of producing natural phenomena we haven't witnessed. There could be exotic ice compositions or internal structures creating these effects. We've only confirmed 3 interstellar objects in human history, but we can't rule out possibilities that sound like science fiction, not based on speculation but on measured data that doesn't fit our models. And that brings us to December 19th. On that day, 3I/ATLAS makes its closest approach to Earth. Every major telescope, Hubble, James Webb, massive ground arrays, will lock onto this target. We'll capture spectroscopic data revealing precise chemical composition. We'll image it at invisible wavelengths. We'll measure rotation rate, map surface features, calculate exact mass. This is our best and possibly last chance to answer. What is 3I/ATLAS? Whatever we discover, one thing is certain. This object has rewritten what we thought we knew about interstellar visitors. It traveled billions of years through the void, arrived during our sun's peak activity, and violated nearly every principle of comet physics. That's not opinion. That's documented fact. So here we are. In less than a month, on December 19th, this object will pass within viewing distance of every major telescope on and around Earth. We'll finally get the data that could answer the question haunting scientists since summer. What exactly is 3I/ATLAS? Think about what we've just witnessed. An object from another star system arrived during the exact 11-year window when our sun is most active. It brightened 400 times beyond normal limits. It fired jets directly into solar wind that should make this impossible. It accelerated at 100 times the rate of the most active comet we've ever studied. And every measurement, every photograph, every data point comes from NASA's own satellites and observatories. This isn't speculation. This is documented, peer-reviewed science that doesn't fit our models. And December 19th will either give us a natural explanation we've never encountered before, or force us to rethink what's traveling through our solar system. Whatever the truth is, I'll be here breaking it down the moment those telescopes capture their data. If you want to know what happens next, hit that subscribe button and turn on notifications for Galactic breaking news so you don't miss a single update. Drop a like if this story blew your mind and tell me in the comments, what do you think 3I/ATLAS really is? Your theories might be closer to the truth than you realize. This is just the beginning. I'll see you on December 19th.